Okay, so here we're looking at the first problem that's in the Arrhenius Made Easy packet. And these would be kind of typical of questions that you would see on an AP free response question. So the first part, is this reaction fast or slow? So the thing we're going to look at with the data that we're given to determine that is the rate constant, or K. And if we look at these, we see that these numbers are really, really large. And so if K is much, much greater than 1, then our reaction is going to be considered to be fast. Okay, so that would be our justification, is the large magnitude of the rate constant is the reason that it is considered to be a fast reaction. Then the next question is, what is the overall order of the reaction? And remember, for that we look for the units of the rate constant. So here it's liters over mole seconds. And so here, this part, right, that's just the inverse of, or the reciprocal of molarity. So that is the same thing as molarity minus 1 seconds minus 1. And based on that, right, it is a second order equation because we had to cancel one molarity, which would leave 1. So it had to be a molarity squared. Okay, so now we're ready to use the data because the next question is, what is the activation energy for the reaction? And so in the previous video, right, we said that if you do an Arrhenius plot, natural log of the rate constant on the y and 1 over the Kelvin temperature on the x, that the slope of that plot is equal to the negative of the activation energy divided by our R, our energy R, the 8.314. Okay, so we're going to go into our two variable statistics. And so this is after I've already modified my headings in my numeric view. Okay, so I'm going to go over, we're going to use temperature and rate constant. So I'm going to go over here and I'm going to put in our temperatures, 260, 298, and then our values for that, we've got, whoops, not negative 9, go back, okay, so now I've got my data in. So I'm going to go back to my symbolic view. I'm going to make sure that all of my graphs are turned off except for the one where I'm going to plot, which is S4, is where I'm plotting 1 over the temperature and then the natural log of the rate is the y. Now, my temperatures here are in Kelvin. So I'm going to go here where I have my temperature. And this is currently set up if it were in Celsius. So I'm going to go in and edit that. And the only thing I need to do is go and basically delete that plus 273 on there. Okay. And I'm going to plot. Okay, so there's my line. Go back to my symbolic view. And for the S4, okay, I see that, let's move this down a little bit. So I see that my slope for this is equal to negative 1435.7, which is equal to negative activation energy over the 8.314 R. So go back into my function app and we get negative 1435.7 times 8.314. Okay, and I'm getting that my activation energy is, oh, I forgot to put a negative on the 8.314. So that's actually going to be positive. Activation energy will always be positive. So 11,936.4, and that's in joules. okay, right, which would be 11.9364 kilojoules. All right, so then the next question is, it wants to know, well, if I change the temperature to 455, what will be the rate constant? So remember here that my y variable involves the rate constant, y is the natural log of k, and then my x variable involves the temperature, so it's 1 over t. So I'm going to go now back to my two variable statistics and the symbolic view, and I'm going to go down and copy my equation. So copy, and then I'm going to go out and go to the solver app, and I'm going to paste that equation in. Okay, so now I have pasted the equation in there, and remember it doesn't have the y equals on it. So I'm going to go over and put the, okay, so we're going to go alpha y and equals, hit enter. Okay, then I'm going to go to the numeric or the number view, and I'm going to put in for my x, so I want 1 over 1 divided by 455. So you can put that right in there, just like that. Enter, and then I want to solve, and so it tells me that my y value is 24.9, which is equal to the natural log of k, right, which means that k then is going to be equal to e to the 24.9, which is, go back out to our function, and we're going to go e to the 24.9, and that gives me a big number, 65. Let's do it in scientific notation. Whoops. 6.5 times 10 to the 3, 6, 9, 10 to the 10th. Right, and again, that would be m to the minus 1, s to the minus 1. Same units. Okay, so now we're going to look at one where it's asking for temperature, so it's looking at our x variable, and it's giving us our y. So it's giving us our rate constant, which we can use to get put in for y. So back to my solver, it still has the equation in it. So I'm going to go to the numbers, and in y, I'm going to put the natural log of 22.5 e9, and then the x, I'm going to solve. All right, so it's giving me that x is going to be 2.95 times 10 to the minus 3, which that's equal to 1 over t. So that means that t is equal to 1 over 2.95 times 10 to the minus 3, which is 1 divided by 0.0025. So I'm getting around 339 Kelvin. Okay, let's look at the next problem. Okay, so here, got another set of data. First question is the reactant fast or slow? We're looking at our K value, and here my K is much, much less than 1. So that is going to be slow. And that would be, again, that's my justification for my answer, the magnitude of K. And now it wants the activation energy. So again, I'm going to go to my two variable stats, and I'm going to go over to put in my temperatures. Now, these temperatures are in Celsius, but no worries, we will get it to put them in Kelvin in the symbolic view. So we're just going to put them straight in as Celsius. 340, 360, 380, 400. Okay, and then my rates, 2.88, 4.87, 7.96, 1.26, 1.94. Okay, so now we're going to go symbolic view, and it's like last time, my only one checked is my S4. And so now here, right, my temperatures are in Celsius, so I got to edit that. And I'm going to go down here and put temperature and then plus 273. Say okay for that. All right, so then now I'm ready to plot. Okay, looks good. Go back to my symbolic view, go down, and here's my equation. So I have that my slope is equal to negative 9515.6, which is equal to negative EA over 8.314. And so that means my activation energy, go back out to here, and I have a negative 9515.6 times a negative 8.314, and that gives me 79,112.7 in joules. Okay, now again we've got some of those similar questions, so I'm going to go back to two variable statistics, symbolic view, go down, I'm going to copy that equation, and then go back, go to the solver, and I'm going to paste that in there. I'm going to go over and put my y equals. And, okay, so I have alpha equals enter. And go to the number view, and this time here, all right, so I'm, oops, look, excuse me there. All right, so again, y is natural log of k, and then x is 1 over my temperature. So it's giving me my x. So I go to my x, 1 divided by 640, and then go to my y, and solve. So this gives me that my y is negative 1.675 times 10 to the minus 3, which is equal to the natural log of k. All right, so that means k is equal to e to the negative, we'll do 0.001675, which is equal to, go back here, and do to the negative 0.001675, and I'm getting 0.9983. Right? Okay. Go back and double check. For some reason that doesn't sound familiar to what we did in class, but we did it towards the end, so maybe I'm just not remembering it right. But let me just double check my data here. 20, 40, 60, 80, 400. Okay, that seems, and if I go to my symbolic, okay, that is the equation I was using. Okay, so I'm going to assume that that is okay. So now let's go back. Let's do the other one. So, and I'm going to have to go back to my solver. And it wants, so temperature is related to my x. And rate constant is related to my y. Okay, so here, go to the number view. I'm given my y, so y is going to be natural log of 50.5 negative 4. Solving for my x, so my x is equal to 0.001385, which is equal to 1 over temperature. So that means my temperature is 1 over 0.001385, which is going to be 1 divided by 0.001385. It's going to be 722 Kelvin. Okay, in the next video, I'll go over the number 3 and number 4, which were assigned as homework.